Hey everyone, welcome back to another deep dive with us. Have you ever wondered what's really going on inside those, super smart large language models or LLMs as we always call them? Well, today we're going to be taking a deep dive into some really fascinating research to see if those impressive chain of thought explanations they give us are like genuine step-by-step thinking or
Right.
just like clever storytelling, after they already know the answer. Just think about it for a sec. When you explain something, do you always retrace your exact thought process?
Yeah, that's a good point. It's a question that kind of goes beyond just, getting the right answer. Like if we want to actually RELY on these LLMs for, important tasks, we kind of need to know if their reasoning is trustworthy, right? Like
Hmm.
imagine relying on an LLM for something like medical diagnosis or financial advice. I mean, understanding how it arrives at its conclusions becomes super crucial.
Oh, absolutely. Yeah, for sure. So the source for this deep dive is a brand new research paper, actually. It's called Think to Talk or Talk to Think, when LLMs come up with an answer in multi-step reasoning. Catchy
Big.
title, right?
Yeah.
So in this paper, the researchers gave different LLMs a bunch of different math problems. You can actually see these problems in table 1 of the paper if you want to look it up. They're pretty simple problems like A equals 1 plus B minus 3, B equals 2 minus 2, what is A? Kind of stuff like that. But the really interesting thing is they didn't just want to see LLMs, LLMs could solve it. They wanted to know when each piece of the puzzle clicked into place.
Right, yeah. And to do that, they use these things called probes. You can almost imagine them like tiny sensors that can tell you when the LLM has figured out part of a problem, even before it starts writing out its explanation. So it's not really mind reading, but it's more like looking for patterns in the LLM's internal data. You know, those patterns that signal, aha, I got this part.
Okay, so they're watching these LLMs solve these math problems, and they got these probes to see what's happening step by step. So what did they find?
Well, for those simple single step problems, most of the LLMs actually had the answer figured out before they even started writing anything down, which kind of supports the whole, think to talk idea. They've already done the thinking and now they're just telling you the answer. But when things got a bit more complex, when there were multiple steps, the LLMs actually seemed to work it out as they went along.
So for those tougher problems, the LLMs weren't just neatly laying out a pre-solved solution. It was more like watching someone solve a jigsaw puzzle, like figuring out one part while they're still searching for others.
Exactly. Yeah, it's a much more dynamic process.
So it's not just, a simple input-output thing. There's actually some real problem solving happening in there. But how do we know that figuring out those intermediate steps actually matters for the final answer? Is it just a coincidence, or does figuring out, say, beep, actually cause the LLM to get the whole problem right?
That's a really good question. And to figure that out, the researchers did something pretty clever. They actually messed with the LLM's internal data. They forced it to have a wrong answer for B. It's almost like, whispering the wrong answer in its ear and seeing how it
Oh,
reacts.
wow. I like that analogy.
And you know what they found? In a lot of cases, this actually led to the LLM getting the final answer wrong as well, which shows there's a direct link, between those intermediate steps and the final solution.
So the LLM's internal calculations for each step really do seem to influence its overall reasoning. But hold on, I heard things get even more interesting. The researchers actually decided to trick the LLM.
Oh, yeah, this is where it gets really wild.
They changed B internally,
Okay.
but then they fed it the correct reasoning chain afterwards.
It's almost like saying to the LLM, we know you think B equals 7, but trust us, it's actually 5. Here's the proof.
Okay, so they give the LLM this fake news about the value of B,
Yeah.
but then they provide the correct reasoning. What did the LLM do in that situation?
So what happened was the LLM actually went with the external chain of thought. It totally ignored its own, predetermined answer for B. It's kind of like it was saying, okay, you're the expert. If you say B is 5, then it must be 5, even though all my calculations said otherwise.
So it's not as simple as the LLM just working through the problem step by step. There's this whole interplay between its own calculations and the information that it's given,
Yeah.
and then how it generates that chain of thought.
Mm.
Maybe wonder if we could peek inside, would its reasoning look anything at all like ours?
Yeah, that's the million-dollar question, isn't it? And it leads us to a really interesting challenge. How could we actually design these LLMs
Yeah.
to make their reasoning more understandable to us humans? I mean, right now, even they're chain of thought. It can feel kind of alien sometimes.
Yeah, definitely. It's like they're speaking a whole different language, even when they're trying to like explain themselves. So how do we bridge that gap?
Well, one idea is to design LLMs that can actually express their uncertainty. Like, what if, along with that, step-by-step explanation, they also said things like, I'm 80% sure B equals 5, but there's a 20% chance it could be something else. Like, think about how helpful that would be when you're, like, relying on an LLM for something important.
Yeah, that would be huge. It would be like the LLM showing its work and telling us how confident it is in each step. We'd be able to see not just the answer, but like the level of certainty behind it. Imagine that in fields like, healthcare or finance.
Yeah.
It could really change how we like interpret and trust LLM advice. But how do you even like teach an LLM to be uncertain?
Yeah, it's a good question. It might actually require a whole new way of, like, training and evaluating them. Instead of just, like, rewarding them for getting the right answer, we could actually reward them for, like, accurately reflecting their level of uncertainty. It's like saying, hey, it's okay to not be 100% sure. Just tell us how confident you are.
That makes sense. So instead of just like spitting out A equals 6, the LM could say something like, I'm 95% sure that A equals 6 based on, what I know. It would add this whole new layer of transparency to their reasoning,
Yeah.
making them seem less like black boxes and more like, partners that we can actually understand.
Exactly. Yeah, that's the goal. But transparency is only, like, part of the puzzle. We also need to make their reasoning process itself more understandable to humans. I mean,
Yeah.
right now it doesn't really reflect how we think.
Yeah, you're right. It feels like they're following some kind of like rigid mathematical logic. While our thinking is so much more fluid, we jump between ideas, we make these intuitive leaps. So how do we get LLMs to think more like US without like sacrificing their ability to be accurate and reliable?
Well, maybe we can, like, borrow some ideas from how we think as humans. For instance, humans use, like, analogies and visual representations all the time,
Yeah.
to grasp these complex concepts. What if LLMs could do the same thing?
So instead of just like throwing equations at us, they could say something like, okay, imagine B is a basket of apples and we're adding 3 more apples to the basket.
Yeah.
It would be like translating their logic into something that's more,
Yeah.
intuitive and relatable to our everyday experience.
That's exactly it. Yeah, it wouldn't be just about getting the right answer, but about explaining it in a way that actually makes sense to humans, bridging that gap between their internal logic and our own way of thinking. But of course, there's a challenge here. Human reasoning is often really messy and nonlinear. We jump between ideas, we make intuitive leaps, and sometimes we even make mistakes. How do we capture that in an LLM?
Yeah, that's like trying to program creativity or intuition.
Yeah.
And isn't there a risk that if LLMs get too human-like in their reasoning,
Yeah.
they might start making the same kinds of errors that we do?
That's a really valid concern. It might actually require a pretty fundamental shift in how we approach AI, moving away from those, traditional rule-based systems towards something more flexible, like maybe fuzzy logic.
Fuzzy logic. I've heard that term before. But honestly, it always sounded a bit fuzzy.
Yeah, I get it. It's a weird term.
Can you unpack that for us a little?
Sure. So fuzzy logic is all about degrees of truth. Rather than just black and white, true or false. It's like saying, well, it's mostly true, but there's a little bit of wiggle room. It embraces uncertainty, which is something humans are really good at.
So instead of the LLM saying like B definitely equals 5, it might say B is likely 5, but there's a small chance it could be slightly higher or lower. It's like acknowledging that even in math, there's room for interpretation.
Exactly. And this could make LLMs much more robust when they're dealing with these real-world situations where things are rarely, perfectly clear-cut. They could make more nuanced judgments considering multiple factors, weighing probabilities just like we do.
It's like we're building this whole new breed of AI, one that's not just intelligent, but also understandable and relatable. LLMs that can explain their reasoning, express uncertainty, and use fuzzy logic to handle these complex situations. It's pretty exciting stuff.
It is. But there's one more big question that we need to tackle, even with all these advancements. How do we ensure that these powerful LLMs actually align with human values and ethics? We don't want AI that's just smart, but also potentially harmful or biased.
That's a huge question, and one that we'll dive into in the next part of our deep dive. Stay tuned. Welcome back.
Oh.
So we've been talking about LLMs and like how they reason and how we can maybe make their thinking more transparent, even giving them a bit of that human-like fuzziness with fuzzy logic. But now I think we need to address like the elephant in the room. How do we actually make sure these incredibly powerful tools are used responsibly?
Yeah, that's the big question, right? We've got these LLMs that can solve these, like, complex problems. explain their thinking, even admit when they're not sure about something. But how do we make sure they're not just smart, but also like aligned with human values?
Right. It's like we're giving them the keys to the kingdom. But we also need to make sure they don't, accidentally burn it down.
Exactly. And one of the biggest concerns with LLMs is bias. They learn from the data that we feed them. And unfortunately, that data often reflects like existing biases in our world, whether it's gender bias, racial bias, any other kind of prejudice you can think of.
So if we train an LLM on a data set full of like biased news articles or discriminatory online comments, it could end up just perpetuating those same biases in its outputs, right?
Exactly. It's like teaching a child with a textbook full of outdated stereotypes. They're going to learn all the wrong lessons.
Yeah, that's a good point. So it sounds like data curation is like really important here. It's not just about gathering massive amounts of data. It's about actively seeking out diverse and balanced data sets that actually reflect a wide range of perspectives. It sounds like a pretty massive undertaking.
It is for sure, but it's absolutely crucial. We need to think about including voices that are often marginalized or underrepresented, deliberately counteracting those existing biases. By showing the LLM a more inclusive picture of the world.
It's like teaching the LLM to be a good global citizen, exposing it to different cultures, different viewpoints, different ways of thinking. But even with like a perfectly curated data set, can we be really sure that the LLM won't like develop its own biases somehow?
Yeah, that's where things get even trickier. And that's where algorithmic techniques come in. We need to develop methods that can actually detect and mitigate biases within the LLM itself, even if those biases are like subtly embedded in the data. Think of it as building safeguards, almost like an internal ethics checker.
So we're giving the LLM a conscience, teaching it to recognize and question its own biases.
Exactly. We want LLMs that can be self-critical, constantly evaluating their own outputs, and flagging anything that might be unfair or discriminatory.
It sounds like we're building this whole new level of complexity into these AI systems, not just intelligence, but also like ethical awareness. But even with all these safeguards, can we really trust these LLMs to always do the right thing?
That's a great question. And it brings us to the importance of ongoing monitoring and evaluation. We can't just set these LLMs loose in the world and assume they'll always behave ethically. We need systems that can track their behavior, identify potential red flags, and alert human experts when intervention is needed.
So even with all these advances in AI, we still need humans in the loop, providing oversight and guidance, making sure these powerful tools are used responsibly.
Absolutely. The future of LLMs isn't just about technological progress. It's about the choices we make, the values we prioritize, and the responsibility we take in shaping these tools for the betterment of humanity.
Well said. It sounds like we've reached the end of our deep dive. We covered a lot of ground today. From the inner workings of LLM reasoning to the critical importance of ethical alignment, it's clear that the future of AI is full of incredible possibilities, but also some profound challenges.
For sure. And ultimately, it's up to all of us to engage in this conversation, to think critically about the implications of these technologies, and to work together to ensure they're used in ways that benefit humanity as a whole.
Well, thank you so much for joining us on this deep dive into the fascinating world of LLMs. Keep those critical thinking gears turning, and we'll see you next time.